Okay, so in this lesson, we're going to be dealing with cubed root because you should see in all of these we have an index of 3. So we will be focusing on that cubed column. And again, we're not going to look at the first row because everything's divisible by 1. So let's get started. For number 1, we want the cubed root of 250. So we're going to strictly look at the numbers in the x cubed column. And I'm going to start with the number 8. 250 divided by 8 comes out to be a decimal, so that means 8 is not a perfect cube of 250. Let's keep going. 250 divided by 27. That comes out to be a decimal, so 27 is not a perfect cube of 250. 250 divided by 64 is also, 64 is not a perfect cube because it comes out to be a decimal. 250 divided by 125 does work out for us though. We wind up with 125 times 2 is equivalent to 250. But let's keep going. 250 divided by 216. That comes out to be a decimal, so 216 is not a perfect cube of 250. And then all the other numbers are larger than 250. So it looks like 125 is our perfect cube. And again, a 250 divided by 125 came out to be a 2. So 125 times 2 is equivalent to 250. So the cubed root of 125 times 2 is equivalent to the cubed root of 250. So I didn't change the value of the expression, I just changed how it looked. I split it up a little bit. Now, which one of these was the perfect cube? That was 125. So this is the number that I'm going to be working with. The cubed root of 125, if we look all the way to the left, it has to be all the way to the left. The cubed root of 125 is 5. So I'm going to take a 5 out of my radical, and the 125 was taken care of, that disappears. And the 2 is going to stay under the radical because 2 is not a perfect cube and it does not have any perfect cube factors. And notice I did write my index of 3. You do have to write the index of 3 because if you just wrote this, then that would mean the square root of 2 because when you don't have an index, it's just automatically square root. So 5 cube root of 2 is equivalent to the cube root of 250. Now let's move on to number 2, the cube root of 48. So we are going to, again, use our chart and looking at the x cubed column only. I'm going to start with the number 8. 48 divided by 8 does work out. 8 times 6 is equivalent to a 48. 48 divided by 27 gives you a long decimal, so that does not work. 27 is not a perfect cube of 48, and all the rest of the numbers are larger than 48. So it actually looks like 8 is our largest perfect cube, and an 8 times a 6 is equivalent to a 48. Which one was the perfect cube? The perfect cube was 8. So that's the number we're going to be working with. And if we look at our chart all the way to the right, the cubed root of 8 is 2. So I'm going to cross off my 8, that disappears from underneath my radical, and a 2 comes out. And then I'm left with the cubed root of 6. 6 stays underneath my radical because it's not a perfect cube and it doesn't have any perfect cube factors. All right, looking at number 3, the cubed root of 108. So let's look at our chart. I'm going to start over from the beginning. So remember, I look at my x cubed column because I'm finding cubed root. I'm going to do 108 divided by 8. That comes out to be a decimal, so 8's not a perfect cube of 108. 108 divided by 27 does work out nicely, though. We get a 27 times a 4. And then if we keep going, 108 divided by 64 comes out to be a decimal. And then all the rest of the numbers are larger than 108. So we can stop. 27 was my perfect cube. So, and the cube root of 27 is 3 if we look all the way to the right. 27 times 4 is the same thing as the cubed root of 108. And the cubed root of 27 is a 3. So I take that 3 out, I cross off my 27, it disappears. And now I'm left with the cubed root of 4. Some of you guys might be tempted to try to take a 2 out of that 4, but that would be square root of 4 is a 2, not the cubed root of 4. Cubed root of 4, or the cubed root of something, means that you're looking for 3 identical numbers multiplied together. For example, in the cubed root of 27 times 4, 27 is essentially 3 times 3 times 3, and then I have a times 4. This is 3 identical numbers multiplied by one another, and we take one of those out, which is exactly what we did here to get that 3. So that's another way of looking at it if that's how you want to look at those problems. All right, number 4, 27 to the 1/3 power. We can rewrite this as a radical, with my index being the denominator of our fraction, so that's 3, so cubed root, and then 27 is my radicand, and then the 1 is the exponent attached to my radicand. So we really have the cubed root of 27. And if we look at our chart, at the x cubed column, 27 is already a perfect cube. So we don't need to split 27 up into anything, because since it's already a perfect cube, the cubed root of 27 is 3. So your answer is just 3. That's it. Okay, next one. We have the cubed root, because my denominator of my fraction is 3, of 64 squared, as the numerator of my fraction is 2. So looking at my cubed root column, 64 is a perfect cube. Cubed root of 64 is a 4. So keep that in mind, because I'm going to rewrite this as the cubed root of 64 times 64, because that's the same thing as 64 squared. And the cubed root of this 64 is a 4, and I'm going to cross off the 64, that's done with. This cubed root of this 64 is a 4, and now everything underneath my radical is crossed off. And the 4 times 4 is on the outside of my radical. A 4 times a 4 is a 16. That is my answer. All right, and then the last problem that we're doing for cubed root right now is going to be the cubed root of 54 squared. Okay, so looking at my chart here. Oops. Actually, I'm going to go back to the notes for a moment, because I'm going to rewrite this to show you guys that this is really the same thing as the cubed root of 54 times 54. It helps to work with small numbers, so I'm not going to do 54 times 54 in my calculator, because that's going to be 2,916, which is a very large number. Let's just work with the 54s, all right, and do the 54s separately. So looking at my cubed column, if I do 54 divided by 8, I get a decimal. So 8's not a perfect cube factor of 54. Doing 54 divided by 27, that works out for us. 27 times 2 is equivalent to a 54. And then all the rest of the numbers are larger than 54, so 27 is the perfect cube factor of 54 that we're looking for. So I'm going to split this 54 up into a 27 times a 2, and this 54 up into a 27 times a 2. The cubed root of this 27 is a 3, so I'm going to pull that 3 out. The cubed root of this 27 is a 3. I'm going to pull that 3 out. Notice how I crossed off my 27s as I pulled the numbers out of 27. And then I'm left with the cubed root of a 2, because 2 does not have any perfect cube factors and it's not a perfect cube, times this 2. And so I have on the outside of 3 times a 3 is a 9, cubed root of a 2 times a 2, which is a 4. Now 4 is not a perfect cube and it doesn't have any perfect cube factors. So that's your answer. You can't pull anything else out of that. All right. So that's our lesson.